Hi and welcome. Before we get started with this week's video, I thought I'd show off a couple stickers I got from Cutting Edge Engineering in Australia. Curtis Allen is the machinist, and Curtis, Karen, and their pup have a YouTube channel that is really enjoyable to watch. They fix large machinery, and they sent me a few stickers at no small expense. Even sending a letter is $3-4. So I really appreciate getting the stickers. I will proudly add those to my board. I always enjoy their channel. It's repairing large machinery parts, so if you like that sort of thing, definitely go check out his channel. The theme of this video is shop-made tools, as a bunch of other YouTubers have done, and I thought I would hop on the bandwagon. I thought I'd start off with really mundane tools that I've made. So these spacer blocks, here and here, were just pieces of metal I cut out to test the flatness of my chuck on my surface grinder. So you put 5 pieces in one case around the surface grinder, and then you grind them all flat, and then you measure the relative thicknesses and make sure your chuck is flat. However, these actually serve another purpose. Like, this set was not for that. These are just ground pieces of stock, and their job is, if I need to, the parallels aren't working on my vise for some reason, or I need some spacers that I know flat parallel and the same thickness, I grab these guys and I pop them under the parts as necessary to prop them up, sometimes off the surface of the milling table when I'm milling and I want to make sure that the part stays parallel. I use these guys. Another very simple part like that are all these washers, and I made some really heavy duty 1/2-inch washers. You can see how thick these are on this end. I made several thicknesses, and these are a very, very simple part. All I did was cut them off on the lathe and grind them so that they were nice and flat and parallel, and I ground them all together so they're all the same thickness. And if you're trying to hold down a part and you want to make sure that you get maximum pressure exerted over the surface if it's a flat surface, these are a great way to do it. And so I made a bunch of these, and I just keep them on a 1/2-inch shaft, and they are very, very handy to have, especially these heavy duty ones. If you want to clamp something down and you're worried about the washer deforming, you don't really have to do that because these have been hardened as well. So that takes care of that problem. And this is a very, very simple shop project. Also, like this guy right here, this part here is a vacuum attachment. So my vacuum hose goes in this side. This is to actually mount it, not to hold the hose in. There's a taper in here that matches my vacuum, and this is just a funnel. And this guy I have used on more than one occasion over on my tool and cutter grinder to suck up carbide dust. Next up is this bastardized looking indicator stand, and it's not actually for holding indicators. So it is a really heavy duty magnetic base with a chunk of aluminum epoxy to the top, and into that is mounted a shaft with some homemade snugs. And this whole setup is to allow me to mount my camera in multiple unusual locations where I can't always get a tripod or something else in to hold the camera. This top plate mounts the camera. This threads in from the bottom, and that stops it from rotating. My camera plate has a fixed hole that's offset from the threaded section. And so this whole thing is to put my camera in some really tough spots, like, for example, over on the bandsaw. So nice cast iron table, or steel table in that case, not cast iron, the magnet can adhere to, and then I can get the camera in really weird angles and get a better shot of the action. Next up, I have the Tom Lipton pipe and tubing bender, and this is a really interesting design. I've got replaceable mandrels in the middle here, and I need to make a couple more sizes, so you're definitely going to want to make a couple more sizes as well. This bottom section mounts in the vise, and like so. And this is where the arm goes, which is just a piece of pipe that I've tapped and threaded some Allen screws on. And you put your material in here, and you can adjust for the size of material, and you wrap it around the mandrel. Now, one thing I would recommend is to make some adapters that fit in here and here that get both closer and farther from the central rotation point. Also, one that sticks out this side. Haven't made these yet, but definitely want to, because I can't get a full 180, but if I had something that's stuck out over here, I could get over 180 very easily. So those are some additions I want to make in the future, but this is the Tom Lipton pipe and tubing bender, and you might want to check it out. He will send you plans for free. He's a very generous guy with a lot of great ideas. Also check out his channel, Ox Tools Company. Next up is a power supply, and I made for a metal etching solution, and you use some templates that you either make yourself or you purchase, like these guys with my emblem on it, and a saltwater solution, and you can etch your symbol or whatever it is you're trying to etch that matches the pattern onto a variety of metals, including stainless, regular mild steel, aluminum, titanium. Actually, I haven't tried titanium. So this etching circuit, you can check out my video on it if you're more interested. It's actually a surprisingly useful solution if you want to put your name on something and you can't afford a laser marker. Next up is a set of tools I made to turn a part on a taper. So a common solution to turn a part between taper is to turn your compound at an angle and then just go in, but you're limited by the length of the compound travel. Another solution is obviously have a taper attachment on your lathe, but that is something that very few of us have. Some of the lucky ones, which I'm very jealous of. And another solution is to offset your tailstock. So if this is the spindle over here and you take your tailstock over here, you offset your tailstock and then you put the part between centers and you turn it that way. But you will notice here that when you do this and you put, starting with a dead center in this side and this side, that you're only supporting the part on 2 points on each side, the sharp tip and the point on the edge where they meet, and that is by no means ideal, especially if the part is rotating over here. Rotating, this is going to score a line around the inside because you're just using the very tip of this as one of the 2 support points. Not a very good kinematic solution. So an improvement on this, which I came up with, are these guys, and these guys fit over the end of a center and they are spherical. And so with a sphere, the part makes contact at a circle at all times unless you exceed, where you run into the support for the sphere. But you can see that you can get a pretty decent taper on here and support the part. So these fit over a center. For example, here's a dead center. Live center is a much better solution. Match the taper. You press this up to the part and it rides on this bearing, and I've got multiple that I've made. Some of these did not match very well. That's why I've got a couple, this one here. And so that allows you to turn a taper much more easily. And so I made these guys. I intend on making another version of these in the future. This side goes in the chuck on the headstock or the spindle side. These were my first experiment, and I plan on making some more using some carbide bearings that I purchased. And that way, if you want to turn a long taper on a normal lathe, you can. Next up is a spanner wrench I made to work on some lenses for a customer. He wanted to get a ring off of one side, and I can't remember all the stuff that was involved, but it was modification of a camera lens. And the spanner wrench is adjustable widthwise, and the tips that currently have little slots in here that I made are also replaceable with whatever pins you want, so I could put points or any other custom design. And they're held in by tiny set screws, standard 1/4-inch pin stock. So that's a very handy tool to have. Next up is another Tom Lipton design tool. This is his surface grinder chamfer block. So if you're lucky enough to have a surface grinder, this tool mounts on the magnetic chuck of the surface grinder, and your part, like this guy, slides right here, and it protrudes ever so slightly through this slot where your surface grinding wheel sticks out, and you can control based on how far back you put your surface grinding wheel how much of a chamfer you're going to put on the part. And I modified Tom's design by just putting another hole in a set screw to mount a diamond point on here so that you could dress your wheel all in one go while you're doing this, so that you don't have to move this out of the way, put your dressing stone down here, lower the whole wheel back down again. You can just do it all very right in line. So I thought that was a handy feature. It's also got screw holes on the bottom, so you can add attachments to raise it up if you need to put feet. and I don't know what else Tom had in mind. Some people did a nice modification and put slots here that would allow somewhere for debris to go, and that's a great idea. I did not do that when I designed this. Anyways, that's Tom Lipton chamfer block that goes on the surface grinder. Next up is a mundane tool, this guy here, which is just an adapter in this case that fits on an MT4 arbor, and it threads on. I also have another version of R8 that also has threaded on the end, and this is my annular cutter holder with the two set screws to hold the annular cutter in place. And that's an annular cutter adapter for my lathe, and I also have one for my mill. Well, actually, this same part threads on the mill. So the only part I made here was this end piece, and it was fairly quick to make and works quite well. Next up is another Tom Lipton designed part adapter for the Kurt vise, and some other tools I made myself. So if you're going to put something round between the jaws of the Kurt vise, you probably want to use a V-block. That way you're going to get 2 points of contact on one side and 1 point of contact, or one line of contact, on the other side. So 2 lines of contact over here, 1 line of contact over here. However, if all you have is a limited size range of V-blocks and you start to go larger diameter, you will notice that the sharp edge here is what is catching on the part, and it will mar the part. So what I came up with was these 2 pieces here that have wider angles than a standard V-block, and the use of them was for larger parts like this, so that the part could still contact the flat part and make 2 line contacts without damaging the part, because again, sharp edges are not good when you're clamping something with a fair amount of force. So these are really handy. I made these before I had my surface grinder, so you can see surface finish anomalies on this. I'd like to just pop these back on the surface grinder at some point and grind them nice and flat. But they've worked great. I've used them a bunch over the years. This is a Tom Lipton project, and what Tom Lipton came up with was, you'll notice these small holes here. These line up with the Kurt vise jaws retaining screw for the jaw face itself. And what Tom had you do was you drill and tap the center of the 1/2" 13 bolt. It's a hex bolt with a small 1032 or an 832. I can't remember with. I think it's 1032 or 1024. And they will actually screw inside the 1/2" 13 Allen head bolt. And then you can, without removing your vise jaws, mount these V-blocks in there on the vise jaws themselves. And if you want to hold a long part at an angle, you are good to go. And the face of the jaw is still back here, so you can actually press the part while it sits in a V between those two, and you don't have to worry about these shifting around. Lining these guys up, I added additional hole. I don't remember if Tom had this or not, I can't remember. So that you could put pins on the vise, so to make sure your V's are lined up. And I reamed these in location so that you can line these V's up very accurately on your Kurt vise to make sure they're not offset, because if they were like this, you wouldn't be holding your part straight, and that would be problematic. There's an exaggerated example. So these are Tom Lipton Kurt vise jaw plates. You could make various angles. You could remake these in multiple angles if you have to do a bunch of parts, and they'd be really useful. Next up is a tool I made to hold an indicator in my height gauge, and most of my indicators are not like this one with a pin on the act, but they have the dovetail holder on it, and this guy lets you hold an indicator by its dovetail on the height gauge. This is not an indicator I typically use on my height gauge. One thing I find is that this dovetail slot tends to vary surprisingly between indicators manufacturers. So if you make it to fit one dovetail perfectly from one manufacturer, if you have a different indicator from another manufacturer, if you're lucky enough, there's a good possibility that it's going to either be tight or loose. It'll probably still work, but it's not going to be a smooth fit. It's very odd that they differ from each other, but anyways, handy tool. Next up is a tool I made just out of aluminum. It's one of my early projects. The clamps are made out of steel, And these guys allow me to clamp a vertex vise like this guy, a grinding vise, onto them, and then they in turn, via these slots here, can be clamped to the milling table. And the advantage is that this spacer is set up to be exactly, well, the combination of this and the bed of the vertex vise, the combination is set up to be exactly the same as the bed height of the Kurt vise, which means I can get an adjunct vise for really long parts on the mill and still clamp them down. A handy part to have. And this was a fun project. This was before I had a surface grinder, so trying to get heights very, very close was challenging. It's kind of fun because turned some angles in here just to match the radius in the ends here of the vertex vise, because I thought that would be a fun challenge. And that project has been useful on more than one occasion. Here's an exceptionally common set of shop-made tools. These are sets of mini pallets. This is mini pallets for fitting in the jaws of the Kurt vise, and this mini pallet system fits on top of the rotary table. So this guy has a bunch of drilled and tapped holes, fairly small, because at the time I thought that would be a good choice. I have set screws in them to keep swarf out of them when I'm not using them, so you unscrew the set screw out and thread in a clamp when you need to clamp in that particular hole. This set of holes here is very square and drilled and reamed for 1/4-inch dowel pins, so you can line a part up and press it against a dowel pin. I made a bunch of clamps for this guy in various lengths. One thing that I kind of screwed up on is I thought these proportionally looked a lot better when they're thin like this. These are heat-treated A2 tool steel, but I've discovered why everyone else's are so much thicker, like Tom Lipton, who obviously knows what he's doing, is because these actually flex a bit. I've never had one break, and since they're hardened, they do not flex too much before they break, so you got to be really careful when you're tying down. In case you were wondering what the pins were for, if you want to put a part against pins, you can do that, or a square part. You can put multiple pins in here and line up your part against the pins, and it will be square and perpendicular to this face. So there you go. There's 3 points. And that's just an example of what it can be used for. So this mini pallet system I've used a bunch, and I've added some V-grooves here also to hold round parts just down the middle, and you can clamp them down the center line like here if you want to. So if you need to drill and tap in there, you can do that. That's another solution I've got. This guy over here uses the same clamps, and it has an alignment center on it for the rotary table. And an interesting thing about that is my rotary table uses these Morse taper 2 MT2 hole down the center, and what I created for it was a bunch of Morse taper 2 to threaded part with a bunch of these different diameter mandrels that go on the end, and including like this long one here. And you can use that to quickly align parts on the rotary table. So not only is this one to align this table here to get this guy centered, so that these concentric circles are also centered, I can just mount a part directly to the rotary table and get them lined up with these various mandrels. And every time I have a new project, I just make another mandrel and then I store them. Here's another one. This one's made out of brass for a much smaller part centering. And I find these to be very, very useful. And I'm sure that if you have a machine shop, if you haven't made a mini pallet system, you will at some point in the near future, the moment you need to hold small parts down in the mill or on the rotary table. Once upon a time, and fortunately only once upon a time, I left the wrench in my milling machine drawbar and got distracted and turned it on with the wrench still in, and it dented the motor and damaged the Delrin bushings inside the drive assembly, and I had to replace those. So I came up with this idea. This is a milling machine drawbar, and what it has is a roll pin here. The center shaft is not attached to this section here, and if it engages with too much force, this pin will shear and allow this to rotate. So if you ever did something as stupid as leave the drawbar in the milling machine again, this would shear and protect you from doing more catastrophic damage. I have however, never actually used this because I learned my lesson the hard way. This was just sort of a fun experiment, turning a really long shaft, which was one of my very early experiences, turning threads in the early days of owning a lathe. And so this was just a fun project. I still think it's an interesting idea, but I think I need to do a better job than this. I think rather than a destructible pin would be to have a bunch of ball bearings with a detented shaft down the middle and spring-loaded ball bearings so that you could adjust how much force it took before this part actually rotated on the shaft non-destructively. Anyways, I thought that'd be an interesting idea. Maybe I'll pursue that at some point in the future, but this was a fun project. Plus, in a pinch, since I don't have a spare drawbar, I guess I do have a spare drawbar. Onto the lathe. So most chucks on the lathe come with really short handles, and these days a lot of them come with handles with springs on here like this one did originally. I hate the damn springs pushing the thing out. I get it's there for safety. It's better to train yourself to never leave the chuck key in the lathe chuck, period. But also, another thing I find annoying about these is that this chuck handle is very short, which means that the chuck being fairly close to the headstock, unless you have it straight up and down, it kind of gets in the way, and it's not very convenient length. So for every lathe chuck I've acquired, I have made my own chuck keys, and I make the part that engages with the square portion of the chuck out of 4140 or 4340. But the handles are 7075 aluminum, and 7075 aluminum is almost as strong as steel, and they have proven to be excellent. I've decided I really like these really long ones like this. I use it quite frequently. This one is for the 3-jaw chuck and the D16 spindle. This is for my 4-jaw chuck, and this one is for my 6-jaw chuck. And I use them all the time. These handles with the really long arms, they do not bend very easily. As you can see, they're all still straight, and you can put an amazing amount of torque on them. If you have a lathe, I recommend making your own handles because the stock handles kind of suck. 3 other tools I made for the lathe that I use all the time right here. This is a tool holder that's meant to be mounted the other direction, but I put and machined off the sides of it and turned it into a vertical shear tool. So there's a slight angle on it. As you can see, it's canted at a slight angle, and you put a very sharp carbide piece in here. And the interesting thing about this tool is that for even material like cold rolled steel or hot rolled steel, you can get a pretty decent finish. The downside is you can only take a couple thousandths at a time max with this guy. Also, the height adjustment on this is not critical, so if you damage a portion of the carbide, you can raise or lower the tool to use a whole new section because this is perpendicular to the axis of the lathe. This guy is a tool I made that's very simple that you've probably seen other people make. It has a ball bearing in it, and all you do is when you're trying to line a plate in the chuck that is at an angle, you push this thing in, and as the lathe is running, it will find its own flat space and get within a few thousandths. It's surprisingly good. And this guy I use all the time, and you can probably tell by the glare that that's a really common problem, is a tool post indicator holder, and I use this all the time. The one thing you've got to remember, this one's got a fairly long travel, is that when you're moving a part down the lathe, if there are parts that go in and out or you have grooves, that you've got to remember to lift this up or you will bend this shaft lickety-split, which I have done once already and damaged an indicator beyond repair. But this is an exceptionally handy tool. You can now buy these. I made this 5 or 6 years ago, but there are other companies that actually make commercial versions of this if you want to, including Edge Technologies. Edge Technologies makes one of these now, so if that's suits your fancy. Originally I made this so that this part cupped all the way around the indicator protected, but when you want to get close to the chuck side, that got in the way, so I just removed the material and now it's just mounted here. Never had a problem with it. Really useful tool. Use it every time pretty much I use a 4-jaw chuck. Here's an odd pair of tools, looking tools for the lathe. This one is the lathe spider. This one goes in the back of the spindle, and it has 4 adjustable Allen screws with nylon inserts on the end, if you can see them. And that allows you to hold long parts in the spindle bore and support them on the other side so they don't whip around inside the spindle and potentially damage it. This tool is one I made really early on in my career. The top is stainless, the bottom is aluminum. There's a magnet mounted in the aluminum, and I use this tool all the time. People have very strong feelings about this tool, which is interesting. This tool is a height gauge, so in that video I show how I made this height gauge and found the height of the center line of my lathe. And all you do is you take this with the magnet, make sure this is clean, that the way is clean on the lathe bed, and you bring your tool up and you just use your fingernail to find when the tool is right at the edge of this height. And it works great. It's really quick, it's really efficient. I know there are a bunch of other solutions to doing this, but this one is very quick and easy, and doesn't require cutting any stock to make sure you don't get a little, you know, a little pip in the middle. So I prefer this. Joe Piezinski came up with this idea. I got it off of his channel and made my own version of it, and I've been exceptionally happy with it. Me personally, I think this is great. I don't know if aluminum was such a good choice in the base here, because as you can see, I've used it a ton, and even though I clean the bed every time, there are scratches in it, so it really needs to be stoned if you want to be precise. I don't know that your height ever needs to be that precise, but anyways, it's a very, very useful tool and it's worked out great for me. This next item, I don't know if it effectively actually should count as a tool, and I don't know if the location should count as the shop, although some people consider their vehicles a shop. This guy is a part I made to modify my cup holder so that a cup holder could hold my large water container and also larger glasses like the ones you get at 7-Eleven cups. And this was a fun part to make because turning the taper on it was a bit challenging because it's very thin. And I use this all the time. It is a fantastic addition to my car, which has very small cup holders. You've probably seen these spacers before for 3-jaw chucks. I did not make these. These are TTC versions. Royal sells some of these, and the set is some insane amount of money, $400 or $500, but they're flat and parallel. They have magnets on the back, and they attach to the face of the 3-jaw chuck and let you set a flat part spaced out from the back of the chuck, but still parallel. And they come in different sizes so that you can have your part spaced towards closer to the end of the jaws or not to work on very thin parts. So I needed something like this for my 4-jaw chuck, but I thought as long as I was going to do this, let's make it adjustable. That's where this kit comes into play. So my 4-jaw chuck has T-slots in it, and what these guys do is they bolt into the T-slot. Here, this aligns it so that it can't rotate in the T-slot, and they either use these custom-made round that fit in the corner of the T-slot T-nuts, or some other T-nuts I made. The problem with these is they don't go all the way in the corner because the way the T-slot was cut, it's round on the end, and this only gets sort of close to the end. So if I want to get even closer, that's what these guys are for. The little brass piece sticking out so they don't rotate inside the T-slot when you want to loosen and tighten them, and this will go either way. It works pretty well. So I've got a selection of things that screw into these, and this is 1/2 20 threads. So I've got Allen screws to set height. I have these guys that I machined off the faces of them to be flat and square that you can screw in here. So I've got a whole range of heights that you can set, and what you do is you mount all 4 of these in the chuck jaw face, and you come around with an indicator and you set it on each one to make sure they're exactly in the same plane, flat and parallel to the face of the lathe chuck. There's also some smaller ones here that do the same thing that allow you to go inside the chuck face. So the chuck jaws, this goes towards the outside of the chuck jaws. This one goes towards the inside of the chuck jaws. Although they do rotate and you can use them either way, this just gives me some more flexibility. I found that I needed it in a couple projects, so I built these to go with it. Next up is a set of tools that I use to set the angle on my lathe compound. So this was my first design idea. It did not work out great. Among other things, the epoxy did not hold the magnet very well in this hole here. That magnet's still there, but you would stack up gauge blocks in a very small sign bar and set an angle on your compound. So I made this version later. This is a much better version. So this goes on the other side of the compound, and this is ground edge on this side, and the sign bar mounts on here like so. If you want to do this angle, or if you want to go in this angle, you stack your gauge blocks here. There's all ground and square, and then you run an indicator along this side to set the angle of your compound on your lathe. And I find this is great for cutting tapers very accurately. I would love to have a taper attachment, but sadly I don't. So this was my next solution. It attaches to the top of my compound with these 4 magnets, and they've been ground flat with the rest of the surface, so they make really good contact and hold extremely well. So this is a tool I've used more than once and very handy. This next tool is not obvious in its function. So this piece here screws on my quick change tool post, and you extend, this part's adjustable so you can extend it out to the center of the spindle, and then this guy slides in and out to set a depth stop for a part you're working on. So this guy works with the quick change tool post and a hole that's threaded in it already, and allows you to set up a work stop, part stop in the front when you're working on parts. And what's interesting is you can set this guy out past your part. So if this is the spindle, you can have it sitting out here. You can bring it in when you want to set your length, and then your cutting tool can be over here, and the cutting tool won't engage until this guy is out past the edge of the tool. And that ends up being a very handy thing. I learned this one from Joe Piezinski, and immediately built this, and I've used it more than once. It's a very handy tool. Here are a couple tools I made while I was in school, and one of them was a screwdriver, one of my early projects. It's just a press fit hex Phillips head in there. Probably couldn't put a ton of torque on it, although it was pressed in there pretty good. And this is a hollow handle replaceable end face hammer that I made also, and this one turned out really well. The class called for all cold rolled, and I chose to use stainless. I went and bought my own material because I thought stainless would look prettier. Back to the mill for a second. This is a tooling part stop. So before I had the stop I put on the edge of my Kurt vise, I had this guy, and I still use this guy because the stop at the edge doesn't always work if the part's wider than the vise. You need something like this. There are a bunch of variations on this. This was one of my very early projects, and it's all made out of aluminum. So this goes in the T-slot on the mill. You can set an angle, you can set a depth, and you can set a height. So you can get anywhere you need to set a part stop. Speaking of part stops, for parts inside the vise jaws, I stole this idea from Tom Lipton, and it is a ground and hardened piece of metal that has spring-loaded and pressed against the side of the Kurt jaw here. And you can set your parts here. You see if you put too much pressure on it, it does flex. That's the spring. That's the springs in there that are giving. But you have to put quite a bit of force before it moves at all. Of course, you have the built-in ones for the Kurt vise jaws, but this one turns out to be really handy. And you can set a 0 in your DRO and keep coming back to it. And when you're not using it, you just flip it out of the way. And I find it to be very repeatable within a thousandth. Next up is a tool that I've shown multiple times and that I've just recently upgraded to the Michutoyo scale on here, and that is my tailstock DRO. And I find this tool to be absolutely indispensable when you're trying to drill to a depth. This hole, I built this piece on the end and this piece right here to hold it, and I use this all the time. That is a fantastic addition. All right, for now, for my last 2 projects, this is the steady rest that came with my lathe, and I think it has something like a 3 or 4 inch capacity. It wasn't enough for a project I was interested in, so I made my own. Here's the steady rest I made, and it has a much, much larger capacity, as you can see. I built it originally so I could turn a dive tank, so you can tell the diameter that it can easily fit. It probably could go even a little larger than a dive tank right there. I don't know if that's 6 or 8 inches, something like that. Probably 8 or more. I forget, it's been a while. One design flaw in this is that I use these small ball bearings and you can't put a ton of force on them. So I have some needle roller bearings that I'm going to replace these with next time I use this, and they can handle a lot more force. The one thing to note is you don't crank down on this guy when you're using it. If your part is out of round, you've got to machine a round surface for it to go on, or you will destroy the bearings. So this one works fine as long as you've got a round surface. The problem was the dive tank, when I was cutting it, kept changing shape on me. So I machined a nice smooth surface on it, and then it would turn around and warp on me as I removed material on the inside because there was a ton of internal stresses. So this was a really large project that I made, and it's one of my early ones. I learned a ton doing it. This was plasma cut material, and it wasn't flat, so there was a lot of machining. Just holding parts this big on the mill was really challenging, especially to bore these holes all the way through. Very, very challenging. A lot to learn here. Last up is my most ambitious project ever, and that was the belt sander from scratch. This is a 6x48 belt sander, and it works quite well. It's a little bit loud and noisy, but functions really well. This is the adjustment for centering, and then you tighten set screws to keep that centering adjustment locked down. That's why this is a little bit loose, because it doesn't actually need to be tight to hold this height here, which tilts this back and forth. It has a handle over here that is that sets belt tension, and because it's a worm gear configuration, I never needed to lock it down. It does not self-loosen. I thought that was going to be a problem. In the bottom, I have a 3D printed dust collection solution, which is so closely fit to the side of this that it works really well. The material gets stuck here, but so one thing I didn't count on, I had my friend 3D print this, was that this swarf coming off the wheel was so hot that it actually melted the plastic. But all in all, it works very well and does very good job with dust collection. These two slots here attached to this port over here, and with the vacuum cleaner, it collects 99% of all the dust that's being made. Again, just the one problem is that I'm getting buildup over here of molten swarf because it melted the plastic, which if I thought about for even 2 seconds, that would have been obvious, but I did not. And that about covers the subset of tools I can think of right now. I'm sure there's more. Hopefully I'll be making more over the years because I really enjoy it, and also it's why I chose the name of my channel the way I did, because making tools is the most fun for me. I hope you find it useful, and I'll put links below to videos where I made the individual tools, if I remember, since I always seem to forget that part. But thanks for watching. Hope you find it useful. Hope to see you next time.